So good morning everyone. My name is Michael Barbero. I have a confession to make. I was a monolithic developer, but I'm happy to say that today I'm sober from monolithic development and I know modularity addict. If you are attending to this talk, it may be because you don't know OSGi very well, or maybe because you already use it and you are asking yourself, ask why, if that OSGi is complex because people that thought about OSGi were crazy, or is it because it tried to solve a complicated problem? I hope that by the end of the talk you will know that the problem is complicated and OSGi is not complex accidentally. Does anyone know about this cartoon? Pretty famous. Essentially, it summarizes all the talk. Why do we need a module system for Java, and why OSGi is providing an answer to solve, not to laugh again at this kind of cartoon. Who is the culprit? The fact is that Java, by default, offers you a very easy, low-cost and low barrier to entry to create and to develop and launch your application. And the fact is that this very low-cost mean to launch an application makes you think about assumptions that could not happen in a modular world. If you make this assumption, you will not be able to move from the monolithic world to the modular world. Some of these assumptions, I presented here six of them. We will discuss about each one during this talk, and we will try to see how OSGi is providing us an answer to this wrong assumption to create modular application, and how this assumption breaks the modularity principles, which is the following one. If you want to create if you have a modular application, normally the changes needed to support evolution of a subsystem, of a subcomponent, should be very small in regard of the desired change or the change of the dependency. If you do not respect the modularity principle, you may move from Java development to this kind of Java development. So the first one is the environment, the execution environment. When you are creating your application, the context matters. You have some gyro installed on the computer, and most of the time we start very quickly without noticing if it is Java 6, Java 7, and so on. And the fact is that Java does not constrain you to specify the required environment to where you will deploy your application. So this assumption that the production environment will be the same as your development is completely wrong. And OSGi starts by providing you the means to specify this environment. You can see three of the main profiles of OSGi. The green and the blue one are focused on the mobile device and connected device. And the orange one is about the classical G2AC version. And you can specify your execution environment through a directive into your manifest file of your jar, and you specify on which application, on which environment your application should be executed. If we try to construct the infrastructure diagram of OSGi, this execution environment specification is the first layer just atop the operating system and the hardware you are working on. The next layer is quite complicated, and it regroups 3 of the assumptions displayed there. So the first one is when you mix up the artifact identity and the module identity. If you try to think about your program as a set of artifacts and just assembling your application through some path, URL, and to express your dependency between artifacts as a relative path between them, your application will be very fragile. So you have to think as module and to specify an identity to your module instead of thinking about the artifact. So Maven could do that. Here you can see the declaration of the module Guava in Maven. And of course, OSGi also provides a way to give identity to a module, a bundle. A module has a name, an identity. The module identity is composed of a name and a version. These 2 components let you express the dependency wherever the artifact is and whatever the form of the artifact is. So Maven is very often used to this kind of dependency, and that's all it does. But OSGi also provides a way to express this kind of dependency through the require bundle directive in the manifest file of your jar. And this is the very basis of the module layer of OSGi. But it also provides more features than just the identity of your module. And it breaks the following assumptions that Java visibility, so the private, protected, public visibility of your classes and methods are sufficient to create boundaries between your different models. So you know that you want to make boundaries to know who is responsible of a certain behavior, because good boundaries make good collaboration. But in Java, without any module system, there is no way to constrain the visibility of packages between users. So here, I display a sample application composed of my app jars and a loading framework, whichever you want. And in this situation, without a module system, every package has access to every other one. So the implementation package of my loading has access to the 2 packages from my application, and also in the other way. But we don't want either our implementation package from my application or the implementation package from the framework library to access each other. So we want to define a model, something that encapsulates the package and lets you decide which packages are visible and which one are of the responsibility of the bundle only. And OSGi lets you do that to define some package that will be exported, the one that crosses the boundaries of the module, and for the one that will be private and then not accessible to other bundles. So here, the framework does not have access to the core, but have access to the exported package of the core. And also, within a single bundle, all packages have access to each other. This is done through the directive export package within your manifest file of your jar. This is quite simple, just make the package, but the main thing is that you can version the package that you export. And this is very, very important because behind this version number, you are putting semantics, you are putting some contracts between you and your users. Because in OSGi, this version number carry a semantic which is explained into a paper, a website somewhere. The semantic versions of a package carry the compatibility contract between your user and your own packaging. Basically, it means that two different major versions of a package are not compatible in and two minor different versions of packages are compatible in some usage, but not all. I will come back to which usage just after. So within this module, we have now added the encapsulation of your packages. We have identity and encapsulation. It also breaks another assumption, which is that a class, a Java class object, after it has been loaded, is identified by a unique name, meaning that only one class can be loaded within an application. Let's have an example. I got my application and I want to use a login framework. Okay, so a little bit after, I want to use another framework which also uses the same login framework. Everything is fine until the other frameworks, the XXX frameworks and my app are using the same version or compatible version of the login framework. But as soon as the two application and the XX are using two different versions, which class will be used? Because by default, Java do not allow you to load two classes within the same application. So let's have a look at how an application is built. It is composed of several modules and several classes. And when either my application or the XX framework is asking for a class from the login framework, it has to go through all the class paths, but it has to go through all the class paths linearly until a class not found if it doesn't find it. And this resolution, this linear resolution of your class within a classical Java application makes you think that the class identity is the name, but it does not. A class object identity is composed of the qualified name and the class loader that loads it. And if you create a class loader, you can load the same classes again. If you create another one, you can load yet again another class with the same name. And this is exactly what OSGi provides you. It is a module system based on class loader who does not create a linear class path, but a class path with dependencies between bundles and lets you load more than one version of a single class. So let's come back to this view of my application with two bundles, two private packages, and two exported packages. But before I show you that I want to import an exported package, but I'm not going directly to this exported package. I go through a statement in my bundle that I want to import this package, and it is the import that will resolve to the exported package. What this white box is doing is I'm looking through all the install bundles within my runtime. If there is one bundle that satisfies my constraint, I will ask him to load this class, the class within this package, through the class loader of the containing bundle and not mine or not the parent class loader. So it breaks the linear resolution of class loading and comes with finally a very simple class loading policy. This can be done through the import package directive within your manifest. But here you can see that I can specify the version I am importing. You can specify a single version, but this is not very flexible. So OSGi lets you define the range of version that you want to import. As the version should carry the semantics of the compatibility, you may be able to import a range without noticing it. Because you want to be able to work with every new version that contains only bug fixes, and you want to be able to use the new one without changing your own bundle. You want to minimize the changes needed to upgrade your dependencies. This is the modularity principle. And obviously the range that you specify depends on your usage of the import package. If you are only a consumer of the package, you may want every upgrade that do not break you. But if you are a provider, if you implement, for instance, an interface, you have more constraints regarding the binary compatibility against the interface. So you have to specify only the next minor version. So it is the pattern, the typical pattern, depending on your usage of the exported package. So, does it solve our issue where I want two versions of my logging framework simultaneously within my application? Let's go back to this view, but add to it the XXX framework and the new version of the logging framework. So I got two versions now of my logging framework, the 1.01 and the 2.3.0. And as I specify the range that I want to import in my application, and the XXX framework also specifies the range of version that you want to import, you see that the two are going to different versions, and there is no connection, no communication between the two bundles. Each one has its own class loader, and then you will have the two classes loaded twice by two different class loaders within your application. So this is the module layer. It provides you the identity, the module identity. You can express your dependency between modules. You can encapsulate, you can hide implementation details thanks to this layer. And you can also express your dependency based on requirements, based on what you import, with a very precise semantics through the versions. The next assumptions is that the permission, so it is the location in the Java memory where all the classes objects are stored. It's a very common assumption that the permission, because of its name, is permanent. So that once a class has been loaded, it cannot be unloaded. This is true when you have a single application class loader, when you have only all your classes are loaded through the main application class loader. Because if you unload this class loader, you are unloading other class and all your application also. But OSGi is adding to the module layer a lifecycle management, which allows you to add and remove bundles. They can come and go anytime during the runtime's lifetime, and they are following the following specifications. They can be installed, and then they are resolved against their dependency through the import package and require bundle. And once they are resolved, they can be started, and they can be stopped to return to the resolved state, and obviously they can be also uninstalled. And once they are stopped and uninstalled, their class loader are not referenced by anyone, so the garbage collector can do his work, and they may be the class loader and the class is loaded by the name may be garbage collector. You can hook into the activation policy through the bundle activator directive. This is a directive that lets you provide a class that implements a very small interface where you are just the start and stop method, which lets you add some initialization once your bundle is activated. And you can also provide the policy that there is only one policy available in OSGi currently. It is a lazy one, meaning that your bundle must be activate and be started as soon as one class of your bundle is asking for being loaded. If you do not provide this policy, it is up to the framework to decide whether to activate or not the bundle, and it is up to the administrator of the runtime to decide to start or not the bundle. So we can manage, now we can install and remove bundle anytime in the framework. And the last layer within this infrastructure provides you a pattern, functionality that makes factory, listener, and many other patterns quite outdated. The reason behind factory or listener patterns are to separate implementation and interfaces. So we can think that it is a good path to modularity, but in fact they are just a workaround around the issue of separating implementers and interfaces. What does it mean? Here I got a very simple situation. I got a consumer class that wants to use an object that will be an instance of a class that implements a certain interface. And I have a provider class that will extend this interface, and those instances will be able to be consumed by the consumer class. How should we give a provider instance to the consumer? A very simple pattern is a factory one. We are just delegating the instantiation of the provider to an intermediate object, to a proxy object, which is a factory that will do the instantiation. But we are just doing an iteration and just adding a new problem to the initial one. So the factory pattern is not so good at separating implementation and interfacing. The other one is the listener pattern. In this one, if you look quickly between the two, in fact we are just flipping the role between consumer and provider. Now the consumer is implementing the interface. It could be a selection change listener, for instance, in some GUI framework. And the provider class is now using this interface, but also implementing another interface, which is a provider interface, a selection provider, for instance. And the consumer will be given to the provider through this provider interface. But still, the two implementations are very, very tight. They are tightly coupled, because we have to give the instance of the consumer directly to the instance of the provider. So that's so useful too for separating implementation and interface. A more recent pattern is the dependency injection one. This one is about devolving the instantiation of the binding between interface and consumer to another object, and this will be the only object that we know this binding. it's a very good pattern. It separates clearly the provider and the consumer. The problem is that it still holds the life cycle of the consumer. It is not the consumer, the provider who instantiates the classes, and the consumer class has no context for retrieving the instance of the provider. OSGi provides microservices, which is a service layer that lets you do the same thing that with dependency injection, but let the control of the instantiation to the provider, and let the definition of the context to retrieve the provider in the consumer. How does it work? We are with microservices. We are replacing the interface with the concept of service. It is an interface that we are just displaying it with a triangle, and a provider class is registering itself to a service registry, and the consumer is retrieving an implementation by giving to the registry some context. So we let every part of the communication track the control of the instantiation in the retrieval. This shouldn't display like that. Microservices have evolved a lot since the beginning of OSGi, so there is many ways to implement this pattern. In fact, you can do it programmatically or declaratively, only in a more recent version of OSGi. Programmatically, you can directly access to primitive of service registry, or use some service tracker to help you listen to services that come and go. Or you can use some declarative way to create services. The most famous one is declarative services, I think. Declarative service, DS. Or there is another one which is Blueprint, which is basically the implementation of string dependency module, string here, in the OSGi world. So we got our full stack of OSGi. The environment, the modules, the lifecycle, and the services. And now you can build your application and choose which layer you need. Maybe you just need the environment and the module with required handle. In fact, basically, Eclipse is only doing that. It provides services, but services with some sugar and do not handle the lifecycle layer very cleanly. And there is also a security layer which is across all other. Basically, it adds some security manager to Java to handle the installation of modules which would not be signed or something like that. So this is OSGi. And it helps you define, respect the principle of modularity by creating small modules with very high cohesion, and to expose only a certain part of this module and to encapsulate the implementation. And thanks to the services, it also allows you to create a very low coupling between your bundles. Don't be afraid to use OSGi if you did not yet. It's quite old. In fact, it has 15 years old now, so it's quite mature, very mature. It's used in Eclipse since version 3.0, and now almost every application server are using OSGi as their foundation. The thing that is maybe the less mature or not as helpful as we maybe would like, is a training around OSGi. We got two main tools in Eclipse. It is the PDE, the plugin development environment, which was targeting primarily the development of Eclipse plugin, but you can do very native OSGi thing with PDE. And there is also a new one recently, BNP Tools. It is not hosted by the foundation, but it provides some very helpful tools to automatically versioning your bundles and your packages, which is one of the most used parts when you release the bundle. So it's up to you. You may choose your tool, you may choose your layer, and I hope that you will do some modular thing. Don't forget to give feedback, please, on the EclipseCon website. And I'd like to thank you for your attention. And I think I have 5 minutes for questions if you have. Around. Thank you.